have a problem here under chemistry, and the problem is this. The isotope of cobalt has a half-life of 5.27 years. What amount of a 0.07 gram sample of cobalt will remain after 2 years? Okay, so this problem is under radioactivity. And to solve this problem, we'll be using this formula. N is equal to N naught times E raised to the power of minus KT, right? So N here represents the amount of particle present after a particular period of time, right? So remember, we are asked to calculate the amount of particle, the amount of cobalt that will remain after 2 years. So this question represents N. So N represents the amount of particle that will remain after a given period of time. And the given period of time here is 2 years. So N here is unknown, is what we are asked to find, right? Now, N naught represents the amount of particle present before any observable radioactive decay or radioactive change, right? So the value for that is 0.07. So this is the amount of cobalt present before any change occurred, right? So the value is 0.07 grams, right? Now we have E here. E here is a mathematical constant. The value is 2.71, right? And E represents E describes continuous change of a property, right? So in this context, since we are talking about radioactivity, E here describes the continuous change of this element, right? So the value is 2.71, right? So the next thing is our K. Okay, let's begin with T first. T represents the given period of time, which is 2 years. So we have 2 years. And then the last thing here is K. K is called decay constant, right? And from the equation, decay constant is not given. But decay constant itself has a formula, which is K is equal to 0.693 all over T half. Now, T half here is called half-life. And from the equation, value of half-life is 5.27. So we have that 0.693 divided by 5.27. That would give us 0.693 all over 5.27. From the calculator, we have that 0.693 divided by 5.27 is equal to 0.1314. So K, our decay constant, is equal to 0.1314. Now we have to substitute these values into this formula, right? So we now have that N here, which is unknown, is equal to N naught. The value of N naught is 0.07, right? Multiplied by E. The value of E is 2.71. 2.71, right? Raised to the power of minus KT. Now, what's the value of K? The value of K is 0.1314. So we have raised to the power of minus 0.1314 multiplied by T. Value of T is 2 years. So multiplied by T, right? So we have to multiply these two and get a particular figure. So we have that N would be equal to 0.07 times 2.71 raised to the power of minus 0.1314 multiplied by 2 would give us minus 0.2628. So here would be equal to minus 0.2628, right? Then we have to raise 2.71 to this power here, to minus 0.2628. So we have that 2.71 raised to the power of minus 0.2628 would be equal to 0.7695. So here we have that N is equal to 0.07 times, after raising this to this, we would have 0.7695, right? Now, we need to multiply these two figures, 0.07 multiplied by 0.7697. That would give us 0.053. N is equal to 0.0538, right? If we approximate this value, we have that N is equal to 0.054 grams, right? So what this simply means is that the sample of cobalt that will remain, after 2 years of radioactive decay is 0.054 grams.